Cool. Let's get started. Let me just make sure. Cool. All right. All right, let's find an easy problem. That's not easy. Status is to do. All right. Is same tree given the roots of two binary trees Q and A, or P and Q, write a function that checks if they are the same or not. Two binary trees are considered the same if they are structured identically and the nodes have the same value. So it's important to note that we have this tree node object. That's what P and Q are. So this seems pretty straightforward. We're gonna do if P is not equal to Q, P dot value dot val, and then we'll return false. It's the easy way to start it out. And then after we do that, we're going to see this might, yeah, let's do this. Do the question mark syntax. And then we'll return is same tree, E dot left, Q dot left, and is same tree, P dot right, Q dot right. Again, just looking at the properties that we have defined here. So we got to think about edge cases. We kind of handle the null edge case with the question marks. We could actually simplify this. So basically, if the value at the node we're looking at are the same and the left tree is the same as the other left tree and the right tree the same as the other right tree. So we could run this as it is. Let's take a look. Okay, so the issue here is when we're hitting this null case, then they are equal because they're both null. So we'll keep that. We'll do an additional case here. Something like this. So if at least one of them has a value and they have the same value. And the theory is that we won't, if one of these are null or undefined, then when we get to this step, we should opt out because whatever value we have stored will not be equal to null or undefined. So we shouldn't have to worry about going down these is same trees. Cool. And we could kind of look through this. Constraints, not important. Okay, everything else seems unimportant, so we'll just submit it and see how we did. And we do get a, well, they do have null. I guess that makes sense because of how the tree probably prints itself. This is probably the left. This is the root. This is the left. This is the right, which should be null. The left of 5, null. The right of 5 is 15. They're the same if they're structurally identical, and the nodes have the same values. Oh, so I said that it was true, but it should be false. I'm also concerned about the value 0, which is why I don't simplify this any more than it is. I'm thinking that the issue is the difference between null and undefined as a value. Let's do a console log of p.val and q.val. Actually, let's just simplify that. Or maybe I'm just not understanding how this outputs. So we do 10 and 10, that makes sense. 5 and 5 makes sense, but we never do, seems like we never do 15 and 15. Which in theory would be the next step. Like the right side of this P should be 15, the right side of this should be null. Let's do this. That, and then we'll change this to Q. We have a syntax error. We didn't put a period here, we lost it at some point. So yeah, we have 10, 5, 15, and this is the right hand. This is okay. So this is the right hand of that. And so 5 for both of them should be next. The left of the 5, the first one is null. I would have thought it would be 15. It's undefined is null. I think that this should be 5, null, 15, which it is. This one should be null, null, that's correct. This one should be, go here, null 15, that makes sense. DSA roadmap. What are we talking about here? Roadmap SH. So I'm trying to figure out why it's not returning false. Let's just print P and Q. So from here, we're going to the left, which would be null. And from here, we're going to the left, which would be null. Null, null will give us true. But why aren't we going to the right? Why aren't we going to the right of 5? So confusing. You would think that it would be harder to get a true than a false here. But apparently that's not the case. Even this prefers to have null and null, but for whatever reason, well, because we're doing null dot left, null dot right. So when we hit this, we get false. We don't even do it. We should pop out of here with false. Which would mean we don't. And then we would end all of this with false. do if not B and not Q, return true. And then if not B or not Q, return false. And then we can get rid of a lot of these question marks. Submit it. Okay. I tried to make things simpler, but they actually ended up making it more complicated. But we did hit the 0 milliseconds, so that's great. Let's look at what the other solutions had in mind. So they created an inner function here. They had a response or a result of true by default. Basically, there's tree P, tree Q. So they're just like iterating the tree, which is what we did. At the response, at the value, result equals that. I'm kind of curious if, if result. So we'll only do this line if we think it's still a good tree. They could have done this in one if. It's a minor optimization. They probably didn't need to do to return null. Or you could just do return, but you could just have like this, all of these, combine all of these into a single if. Really? It's interesting. What is this? So they did something similar. Depth first search. And what did they do? If not N, return F. Okay, it makes sense that this would be slower. But basically it's concatenating a bunch of Fs and seeing if there's both of these arrays end up being the same. If not, okay, so you're putting the val. They're basically like converting it to an array and seeing if the two arrays are the same. I feel like you could mess with this and give it an input that's not necessarily the same. Because you're just concatenating empty strings here. Like if you had a 10, or you had like 11 and a 110, I feel like you could mess with this and get a bad result. This one had similar ideas to us, where they had some base cases. They did their own stack track. So rather than recursively calling a function, they did some stack tracking. It's a little complicated, but try to keep it simple with our solution. Okay, let's go back to the problem list and we'll do climbing stairs. You're climbing a staircase. It takes n steps to reach the top. Each time you can either climb 1 or 2 steps. In how many distinct ways can you climb to the top? So I feel like some people would think that this is a big O n problem, but I think it's just a complicated math problem that you could do in big O1, constant time. So my instinct is to figure out this math problem. So each time you can either go up 1 or go up 2. And so something tells me that this is basically some kind of n times n solution where you just multiply n by the right constant and add some constant. It's not much of an algorithm. What's the time there now? My current time zone is Eastern time, if that's what you're asking, Sandeep. It's 2 p.m. here. So how many different ways can you climb the stairs? I'm trying to think of how it expands each time. Maybe we can think of it. Let's say if there's like a pattern that forms. So if it's 1, then it'll be 1. If it's 2, it'll be 2 because you can go 2 or you can go 1. If it's 3, it's 1, 2, 3. Welcome. Thanks for joining. Yeah, I used to work with somebody in India, so yeah, I'm familiar. With the 12-hour or so difference. So for the 3, it'll be a little bit more complicated. We could do 3 1s, we could do 2 1, we could do 1 2, which would be 5. But this is saying n equals 3 is 3. Oh, my bad. This is 1. That's just, this one is a 1 combination. Of course it is. And then 4 would be 4 1s, 2 1 1, 1 2 1, 1 1 2, 4 1s, 1 1 2, 1 2 1, 2 1 1, 2 2 2. Is there a formula emerging here? 5 is even correct. We definitely don't want to do this in big O N, so we just want to figure out the formula. It kind of looks like, what's that one? Bernoulli? No, Fibonacci. Yeah, Fibonacci. It's something like this idea that you can do all the previous combinations plus this new one. But in order to do a Fibonacci sum, you need to do recursion. Actually, yeah, this because it's basically the n. It's just a really weird way of doing Fibonacci because you are trying to do f of n plus f of n minus 1, something like that. Oh, good night. Thanks for popping in. With some base cases of if n equals 0, return 1, n is 1, return 1, if n is 2, return 2. It seems like it's Fibonacci, but I don't know. Oh, why did I call it F? But is it? Yeah, I don't think you could do. You could do Fibonacci a little bit faster if you didn't use. If we didn't use recursion, we could do it faster. So we could do const result equals 1. I don't know. Call it other equals 1. And we'll say while n, and we'll return result. These should be lets. And we'll do result equals result plus other. I think we gotta do const temp equals result. And then other equals temp. Something like this. It's been a while since I've done Fibonacci sequence. Oh, we didn't end minus minus. So we put 3, but we expected 2. N was 2. So if you say 0, and that should bring us down by 1. Up is 1, expected 2. And this gives us 3. Alright, let's think about it. Result is 1, other is 1. N is 2, so let's write that down. We'll put this on a new line. Put put a 1 here, put a 1 here. This would be 1. Result will become 1 plus 1, which is 2. Other becomes temp, which is, this should be 2. Becomes 1. So maybe we have to do greater than or equal to 0. The result is 0 initially. And we'll try that. Okay, we can get rid of our comments. Double check, run it one more time. We'll submit it, see how we did. We really didn't have to optimize because we were already at 0 milliseconds, but this is faster because it will be big O n rather than like n plus n essentially. It's actually a lot more complicated than that. It's actually really hard to calculate what it would be recursively, because each left and right call would be another like n minus 1, n minus 2, which is basically big O n. So it's a little complicated. But this is easier. This is just n. A lot easier to reason. We can look at the other solutions. And they did what we did. They created a temp variable. I mean, they did things a little bit different in the order, but we had the same ideas. Look at the solution. They did Fibonacci. And they had like some kind of map variable. And this is just so they can cache certain values for n. So this would save them a few iterations, but this uses more memory. So you're going to use n memory. So that's the sacrifice. You improve performance, but you hurt memory for this one. And then climb stairs. This is also a Fibonacci sequence. And they also cache the values. So this is also using more memory. This is probably also slower because it uses a console log. But I'm happy with that. So we're gonna go back to the problem list. And we're gonna remove duplicates from a sorted list. Given the head of a sorted linked list, delete all duplicates such that each element appears only once. Return the linked list sorted as well. Hello. I'm just trying to figure out your name. Santosh? Santosh? Let me know if I'm saying that right. I apologize. Welcome. Thanks for joining. How's it going? Good. I'm in America. I'm in the state of New Jersey right now. Where are you at? Yeah, I'm joining from the Eastern time, so it's 2:30 p.m. right now, where I'm at. Getting ahead of a sorted linked list. Yeah. 1:05 a.m. Nice. Are you up late coding? Are you coding for fun? What are you up to? Are you usually a night owl, so to speak? Yeah, you vibe coding. Nice. What's your usually when I hear vibe coding, I assume there's some kind of AI involved. Do you have an AI, a preferred AI agent? Cursor. Okay. I've not used Cursor. I'm considering doing a stream where I exclusively use AI, no coding at all, for my thoughts or my actions, just having an agent do it. It is something I think would be insightful. But I have an interview on Wednesday, so I'm hoping to prepare for that. I think it's I think it's challenging to. I don't want to assume how much experience you have, but even being more experienced as I am, trying to get back into LeetCode, when it's not really the kind of problems you solve anymore, it's kind of challenging. I'm not gonna lie. Head of a sorted linked list. Delete all duplicates. Return the linked list sorted as well. It's already sorted though, so this should be easy. And there's always... Where do you work? I am actually currently unemployed. I just didn't align with company, the company I was working at, the expectations that they had, and I guess what I was expecting as well, and those expectations just didn't align. So I'm no longer with them. But I am looking for a new job in the meantime. Streaming when I'm not applying for jobs. I applied for like 15 jobs last Friday. I applied for 2 or 3 jobs this morning. I had an interview today. So trying to get the ball rolling. But it's challenging. Future plans? I mean, outside of, I'm just trying to do everything. I'm trying to see if I can make streaming a thing. It'd be nice, but I'm also considering doing tutoring. I think any engineer always will pretty much have the idea of building something of their own. But I just get so fixated on perfection that I like never finish a project. So at the moment, my plan is just to keep my head above the water, so to speak. What's the average salary? Software development engineer 2-level software SDE 2-level engineer in USD. You may prefer not to answer to. I'm not totally sure on these levels, but I mean, it's not like I'm a hiring manager, so I don't mind talking about these things. But if you're talking about like a senior engineer, senior software engineer in the US, you probably get like between 150 and 200,000, depending on experience and the company. Hello, Tarun. Welcome. We're gonna do next equals head, and we're basically going to iterate the list until we hit the end, and we'll just return head. And we'll look at the current thing and say if head dot value, what is it? Yeah, we got to take into consideration this list node that we care about. If head dot val is equal to head dot next dot val, then we got to say head dot next equals head dot next dot next. YouTube randomly suggests you're live. Oh, thanks for the sub. Appreciate that. Yeah, I wish this seems like a good time to stream, but I've been like doing lives, I've been cutting them in the videos, I've been making shorts. I'm trying to figure out what kind of content people want. I do want to do like more chatty videos too, yapping videos. If they're not equal, then we'll say next equals next dot next. Oh gosh, this is gonna look horrible. It's just gonna be the word next everywhere. I'll call this current, actually, just to make it a little bit easier. And we want to put a question mark here so that we don't do a null pointer exception. What is the impact of AI, ChatGPT and other AI? In India, it's rapidly growing. Maybe investing in it. AI, I don't know yet. AI to me doesn't really work, in my opinion. It doesn't have quite the finesse that a human coder does. I kind of see coding as more of an art than a science, and you know, if you've ever generated an image using AI, there's always just something about it that just screams AI. And if you've generated text, there's something about it that screams AI. And if you've, in the same way, the same sense, if you've generated code with AI, there's just something about it that just doesn't seem correct. Like, it might work, but if you're building really complicated systems that require multiple services to talk to each other, building infrastructure, interacting with existing APIs and whatnot, or with evolving APIs, I just don't think AI is going to be reliable. Plus, you're hearing more recently about how people are utilizing AI, and that AI is doing malicious things like deleting entire databases, or potentially even deleting entire code bases, potentially pushing bad code and taking longer than a human would to push that bad code. Okay, no problem. I'll log on earlier tomorrow, but yeah, it's a conversation. But I would definitely invest more in self-growth and try to use AI. If anything, use AI as a tool to help you. I don't really think it's going to replace humans anytime soon in terms of programming. Alright, I'm gonna submit this. Okay, we got 0 milliseconds, which is excellent. Let's take a look at another solution. And they have similar solution as we do. There's previous, there's start. Start is what they're currently looking at. I guess. Yeah, star equals start, but next. Previous. Oh, this is when previous happens. I feel they did it a little bit more steps than we needed, but that's okay. This kind of looks like our code, but they did an extra and here, and we did a question mark here. I don't know the overhead of the question mark, the optional operator, so I guess it's less than this is, which is good to know. They did something similar. Cool. So yeah, we really only need one extra variable. Did this in big O n, and the memory is big O1. Does not scale with input. So we'll just move on. I do merge sorted array. Now I was given a little tip that this might be in my interview. Something like this might be in my interview, so it'd be good to practice it. I feel like we've done something similar already, but we're gonna do it again anyway. You're given two integer arrays, nums1 and nums2, sorted in non-decreasing order, which in the past I said this is a weird way of saying increasing order, but the reason they word it this way is because you can have two of the same number in a row, and that's considered non-decreasing, but not increasing, so it's very important. Two integers m and n representing the number of elements in nums1 and nums2, which is interesting. Why would you need that? The final sorted array should not be returned by the function, but instead be stored inside the array nums1. Ah, that's why. To accommodate this, nums1 has a length of, that's fair, where m is the element. Okay, cool. So the idea is we need to do a merge sort inline, which is actually fairly challenging. Do we need to return at all? Instead be stored. We don't return anything? Okay. So, I'm trying to think of, we'll do like const left equals 0. We'll do left and right equals 0, and this will be our pointers into this left array and our pointer into this right array. And we'll say while left is less than m, and right is less than n. Something like that. And the next thing we want to do, hello Kushal, I hope I'm saying your name right. Welcome to the stream. While left, we could do just do this so that we exit eventually. We know that we're gonna have to do that anyway. The only problem is that I know that we're going to increase m. At least the algorithm I have in mind is going to increase m. I'm gonna say that we return nums1 just for fun. I don't think we have to. Do not return anything. Okay, it actually explicitly says to return void. So I guess not. Let's not return anything. So I think we gotta do if num sub m is less than num sub right. So if the thing in m is less than the thing in n, then the thing in m needs to stay. Sorry, it should be left. The thing in the left needs to stay where it is, and we need to just move over. So we need to say left plus plus. There's probably more to do. Else, we need to do right plus plus, and then do more. Okay. And what is the more that we need to do for this? I actually don't think there's anything more to do. I think there's only more to do if the right tells us to. I think we need to do num sub m equals num sub left. Nums sub left equals nums. Why am I just doing nums? It should be nums1. This will be right. And then we're gonna do left plus plus, right plus plus. I think even m plus plus. So what is this line saying? It says take the current. Oh, but we can't do that because then it's no longer sorted. This is why sorting in line is harder. So let's think about another way to potentially do this. We are taking the number out of the right array. So rather than doing this, we could do const temp equals the thing in the right. And we say to take the thing in the right, store the thing in the left in the thing in the right, and store the thing in the right back in the thing in the left. Then we don't increase right. Does that even make sense? Because then how do we break out? How do we increment right? Take the thing in the right. Then we can overwrite it since we have it cached, the thing on the left. Then we can overwrite the thing on the left with the temp. And this is because the left is greater than right. So we increment left, we keep right. But when do we increment right? Okay, there's no way that that's correct, because if the thing on the left is greater than the thing on the right, and we move it to the other array, there's no guarantee that the thing on the right is less than, okay. I don't know how to make it not complicated. But keeping this array in order is pretty important. One thing that we could consider doing is do it in place. Like, to me, the only way to do this in place is to sacrifice some memory. So that makes me want to do num sub 1 dot slice 0 and right plus plus. This will be back sub left plus right equals nums 1 sub left nums 1 nums 2 and 2, and then we would just write the array back to num sub 1. So we do sorted dot for each number index, and then num sub index equals number nums 1. Something like that. I didn't change the variable name everywhere. Same. Okay. Okay, cool. So we need the extra steps of while left is less than m. We can actually start inlining some of this. We could put plus plus here, put the plus plus there, and then we'll do right is less than n. Right plus plus. Run it. Cool, we can submit it. I don't think it's the fastest, or it is. I was gonna say, I wonder if there's an algorithm that can actually do this inline quickly. But we did hit the 0 milliseconds. I do want to see what other people submitted though. Okay. They seem to have done something pretty efficient here. Much more efficient than we did. But the idea is to work your way backwards. There's a K, there's a J, there's an I. Whoa. K equals M plus N minus 1. K is less than or equal. Ah, interesting. That's really smart. So they actually worked their way backwards. They started the last thing, and for each item, they put at the end the item that they're looking at. And I think in that case, there's no risk of accidentally overwriting because there's enough space to insert at the end always. So this is actually a really smart way of doing it. Okay, so that's the strategy, and this uses less memory than we did, and it does it faster. Let's look at a slower solution. Interesting. nums1 splice m. So just zero out everything in nums1. Excuse me. And I'm curious why that doesn't, how that's allowed. Oh, it's splicing from the end of the string onwards. I feel like you don't even need to do that. Unless you're pushing. Okay. Interesting. Let I equals 0, nums1 dot length, I plus plus. If num sub I is greater than num, what is num? Oh, num, it's num sub 2. Oh, okay, it's so slow because it does a splice I. Splice I 0 num, which is basically just shifting everything by 1, which is slow. You insert an I, remove nothing, put this element there. What's the point of inserted? We didn't insert it, push it. Okay. And then break. Okay. So it's n squared plus this. It's very expensive. It's an end loop inside of an end loop inside of an end loop. It's very slow. This is the 1 millisecond. Let's look at 2 milliseconds. They did something similar, which is interesting. They actually kind of overkilled it. They could have done this in one operation. But they did an n squared, which again is not great when you could do it in n. Okay, let's take a look at another one. This will probably be the last easy. I'll move on to medium after this. Given a root of a binary tree, return the in-order traversal of its node values. So we want to return an array of numbers, and it's in order. So I would like to do this recursively. And in order to do that, I would want to keep track of the result. And we'll say if, if root we'll do if not root, return result. Else we'll do in order traversal root dot left. We could just refer it up here. This is this tree node object that we're getting. So we're gonna do left, right, and I believe in order. There's prefix, there's postfix, there's in order. I believe in order is result.push root.val. And we'll just default result to be an empty array. And then we'll return result here. We can actually simplify this a little bit. We'll do if root. We can run this. So I imagine it should be 1. It should be 1, 3, 2. Okay, we handle 1 element and 0 elements just fine. So part of me thinks, so this is the root, this is the left, this is the right. It expected 1, 3, 2. This is the root of the right. But it did 3 first, which is the left, right. This should be the left of hold on. Root of a binary tree. 1, 2, 3. There's 1, 3, 2. This is, I guess I don't know what, I don't know what in order means. And then there's the idea that for whatever reason, we're not like processing this right node at all. So I'm curious to log the root each time and see what we get for the result. So we got, this is the output. This is correct. This is the left node. Then we get the right node, which is 2, 3. And then we get the left node, which is just 3. And then we get null, but then we should push 3. Oh. We need to pass this down to each call. So we want to reuse this reference and make sure we push it onto the same reference. This should resolve. Cool. So we'll submit this. We did get 0 milliseconds, which is pretty nice. Let's look at the other solutions though. So they actually have an external variable to keep track of things. And when there's no node, they just exit early. And they just call this recursively. So less arguments. I do generally prefer more arguments, I don't like variables that change over time, really. I know this is doing that, but it's a little bit more predictable when you pass it as an argument, for my perspective. It's a little bit more flexible. They just logged. That's their only issue. If they didn't log, they'd probably be at 0 milliseconds. They also logged, but they logged a little bit more. They did it in the traverse. Was this one in the traverse? It wasn't. So since they logged in the traverse, this one took longer. They logged. and then logged. So I logged in the loop and out of the loop. So the main issue here is just logging. But yep, that's that. I will do a medium now. So let me go to the problem list, filter it, switch it to medium, and let's do generate parentheses. I don't know what this one is. Given n pairs of parentheses, write a function to generate all combinations of well-formed parentheses. Okay. So we're given 3, and then we have to generate this. This is definitely going to require either recursion, probably recursion. Let's just think about it for a minute. Pretty much, first things first, we gotta add a base case. If n equals 1, we return this. Whenever you're doing recursion, you want a base case. But we want an array. Do we need recursion? I'm not sure yet. Maybe we can get away with not doing recursion, but that's my idea at the moment. We could probably do it in a simple for loop. Question is, how do we do these different nestings? There's the idea of just wrapping all of the parentheses with parentheses. And you have parentheses next to parentheses. I guess if n is equal to 2, then we return that. Can we just do that always? Like we wrap everything or there's one next to it. Basically there's like a result. Which is generate parenthesis of n minus 1. And the idea is that that result, we could do a flat map of item, and we could return item. Let's just do it with a template string. That and that. Actually, there's there's also this. Which makes me think that if n equals 2, we should handle this manually. Because this might add an extra variant. Something like this. I wonder if the order matters. Anyway, seems like we didn't do it right. So n equals 3. We should get 1, 2, 3, 4, 5. We did 1, 2, 3, 4, 5, 6. So which of these is extra? We have this, which is part of just expected, but then we have this. And that's because we have this. Okay. Causing me to wonder if we need this and if we need this. Maybe we can get away without them. Okay, let's look at the output. We have the 3. We have that one. Which one are we missing? Let's figure out what are we missing. I see that one. I see that one. I see that one. I see that one. This one is missing. So the question is, how do we handle this edge case? Because now we're at a spot where we're overdoing it or underdoing it. One thing that I would consider, this needs to be 1, 2, 3, 4, 5. If it was 1, it'd be 1. If it was 2, it'd be 2. So it's 1, 2, 5. I wonder if it's a little bit more complicated. Some kind of algorithm where we have to actually manually generate every single pair. It only goes up to 8. So my new idea is something where left equals and right equals 0. And to me, n doesn't even matter. I'll say like if left, then we'll return so if we're able to do a left parenthesis result of parenthesis, put -1 here. Do left -1, right +1. Every time we put a left, we need to put a right. So the right tells us how many more rights we need to do. Pretty much whatever this result is, we need to go through it. Result dot map items item. Basically, if we're able to put a left, then we figure out everything else, and then we put the left on all of those things. Something like that. That's part of the solution. It's part of a solution. I don't know about the most optimal solution. I think we gotta do if not left and not right. Return empty string. If right. This is bound to happen. The only way we get this far is if there are rights, because between this condition and this condition, we're guaranteed to have a right at this point. So const result, I think it's similar. I'll put it in an else just because the scoping looks better. Left remains the same, right becomes -1. And we add the right here. Pretty much the idea being eventually we'll hit this empty string. This empty string will be appended with a right parenthesis, and this one will append with the left parentheses. We could run this. Result of map is not a function. This needs to be an array. Okay. I only got one array. We need to make it kind of balloon. What is going to give us the ballooning effect? Oh, I think we need to do this. This. We need to do both. Then we'll just do this to the left, and we'll just do this to the right. And then we'll return lefts and rights. Hopefully that's better for us. Okay, it does seem better, but it's not correct. 1, 2, 3, 4, 5. We are getting the correct number of elements, but we are getting duplicates. Lots and lots of duplicates. So how do we... Yeah, they're all just... We're always just wrapping, and I guess that makes sense. We only ever add it to the left and the right. Okay, I'm slowly coming back to the idea of my original recursion. If n equals... Except I'm wondering if there's a way to not do it. Return result. We'll do for let I equal 0, I is less than n, I plus plus. So the question becomes, how do we expand this? I am gonna cheat, I think. Just keep track of the things we've added. And what we can do is like n is always 1, so if it is 1, and we set I to 1, as if we've already processed that one. And so what we'll do is we'll do result do let result equals result dot lat map item const keep it simple. We'll do that. We'll do parentheses around item. We'll duplicate that. Put parentheses to the right, or to the left, and then parentheses to the right. Then we'll map over every item. If we didn't added dot has item, then added dot add item, and then we'll say result dot I think this needs to be like this, and then we don't need to do that. And then we would do return false, return true. True, false. Let's try it. Curious. Sorry, this should be filtered. Okay, So we're able to do it without recursion. I want to submit it. Okay, well 4 is incorrect for me. Do we have the right number of items? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Okay. So we're missing 1, it seems. Where else can we be adding a parenthesis? Just very curious. Hello, Dark Knight. How's it going? How do we get this extra? I don't know how helpful it is to figure out which one is missing, but maybe it is. Let's see, what do they prioritize? Okay. Let's do at the beginning of each loop, let's console log the result, and I guess I, and then submit it. So it's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 12, 13. Let's keep note of this somewhere. So our output dot length equals 13. The expected dot length is, this is medium. Which I thought would be doable in a small amount of time, but apparently not. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. We're just missing 1, it seems to me. When we hit 4. Now, thinking of this more critically, this is 1, 2, 3, 4, 5. Let's also log the length to save ourselves some time. Submit it. So thinking about this critically, 5, we should increment it, I would say, by 3 for each one. So this should increment it by, no, it doesn't increment it by 3. It's not that simple because there's duplicates. But in theory, it'd be 3 variants for this, 3, 3, 3, 3. There'd be 15 in the end. So we're cutting out 1. Unfortunately, I can't just run it against. Thank you for the hearts. I'm trying to figure out why it's cutting out. Maybe I can log the ones that I'm cutting out. That'll give us some insight. And we'll submit it. And see if what we're cutting is expected. So, do we already have these both, is the question. Looks like we do have this. And we could just do a Control F. And we do have this. So which one's missing? We're gonna do it the slow way. Did we find the one that we're missing? Hopefully I don't accidentally skip it. So far we have them all. Okay, here we go. This one's missing. So, oh, this one's interesting. This is getting to why I feel like recursion is the answer. This one is just two completely separated pairs. Okay, I'm gonna do this a completely different way again, because I don't think we're getting a solution this way. Do you think left and right are important here? We just need to figure out how to expand it. Something where, like, the idea... Call this function cursively. Why am I calling it rights? It's called lefts. Oh, it's gonna be written like this. That's the difference. Right increases by 1, and right decreases by 1. I would say if left, otherwise it's an empty array. Right, otherwise it's an empty array. And then return then we need to do the base case if left. If there is no left and there is no right, then we return empty string. And then we'll return lefts, rights. I imagine we'll have duplicates in this solution. I need to write this just a little bit differently. We need that parenthesis. Run it. And map is not a function. We learned this lesson last time. I'll run it. Interesting. We didn't spread it. Okay. So we seem to not be adding right to anything. So let's try to think about why that might be the case. So when we first call this function, we should only be going down this one, not this one. And then left, which is n, would become 2, and right would become 1. Okay, so what I'm going to do now is log n lefts and rights. To figure out why oh my goodness. We didn't put enough arguments. Okay, the output is 3 left parentheses. These both need to be 0 in order to go down this line. So this is -1. This is after the fact, after the fact, after the fact. Why are we not going down rights then? Let's do n left, right. Run it. Okay, so right is becoming not a number, which is curious because we have no default value. Nice. Okay, that helped. Let's submit it. See how we did. Okay, well, we didn't perform very well. We could try to analyze why that might be the case. Or if there's anything we could do to make this better. know the string concatenation can be quite slow, so it'd be nice to do the concatenation at the very end if we could. But let's look at some other solutions. Okay, so they actually do use recursion as well. They do also use this concept of left and right. And they see if, okay, interesting. They see if there's enough characters. If so, they push. If there's something on the left, they add to the left. If there's something on the right, they add to the right. Very similar code, but theirs runs faster. They are concatenating too at pretty much every step. So maybe it's just this map that's slow. They did create a simpler function that takes different arguments. There is a spread. Back to the code sample. Yeah, they don't spread. They just push it onto an array. So you do get some advantage to doing code like this. You do bypass some of the slower approaches by having a global variable like this. But it is also pretty easy to read. There's really no real downside of this. You didn't need to say let, but that's minor. Look at the next one. It did something similar. Yeah. Yeah, we could simplify this a little bit more if we add a closure, but I think it's okay. So I'll go back to the problem list and try to find maybe Sudoku. This one I feel like is a lot harder. But let's see what it actually wants. Determine if a 9x9 Sudoku board is valid. Only the filled cells need to be validated according to the following rules. Each row must contain the digits 1 through 9 without repetition. Each column must contain digits 1 through 9 without repetition. Each of the 9 3x3 must contain 1 through 9 without repetition. A Sudoku board partially filled could be valid, but not necessarily solvable. Only the filled cells need to be validated according to the mentioned rules. Okay. Now, there is very likely, we only need to validate the filled cells. We don't need to validate the empty cells, which does make this problem considerably easier. So we got to do the rows, the columns, and the, what did they refer to them? Sub boxes. So basically for let row equals 0, row is less than 9, row plus plus, and it is an array of arrays of characters. So we're gonna keep track of what we've seen so far, and we're gonna call it a set. So we'll do for let column equals 0, column less than 9, column plus plus. We could actually, we could do both at once. We could do both the columns and the rows in a single loop. And that would be faster. Let's do that. Can we also do all of the, we could also do all of the blocks? We could also do all of the blocks. We could, but we probably shouldn't. So we can say scene row, we can say scene column. We'll just say this is X, Y, X, X, Y, Y, Y. And we'll do const scene sub box equals new set. And we'll just assume if we reach this part that it is a valid Sudoku. And so we could do the column check, the row check, and the sub box check. So if column, if we're caring about the column that we're currently in, we'll let X represent that. And so we'll say equals board sub X sub Y. Actually, maybe sub Y sub X, because is it? No, Y is changing more. So, and the X would choose which of these. X is hardly changing, so Y would do these, which is the row. Okay. It's gonna be Y X for the column. It doesn't really matter, but we should be accurate, I would say. So if not seen column, as long as we're consistent with how we're naming things and how we're using variables, we should be fine. If we've seen it, then we'll return false. And then we'll say seen column. We'll just else it, just so that things are nicely grouped together. And then we could do the row, which is very similar code. We'll call this row, and we'll do X, Y. And then we'll do scene row. Scene row, scene row. This is row, row. Yep. And then finally we need to do the sub box. So say const sub X equals something to do with X. And const sub Y is something to do with Y. we'll say const sub equals board sub x sub y. And then we'll do very similar logic again. I think they're both a coordinate x, but this will be plus something y plus something y. We're going to call this sub x, and we'll call this sub y. And then we'll use scene sub box. Scene sub box. So what the x is determining is which sub box we're in. So each time we increment x, we're going to change which x that we're looking at, pretty much. I think we're gonna like multiply it by 3 and divide it by 3. So the idea is I would want to, if x is 0, 1, 2, 3, 4, 5, 6, 7, 8. So I would want to get the values 0, 0, 1, 2, 3, and then 4, 5, 6. I believe 0, 1, 2, 3, 4, 5, 6. Yeah. And then in order to achieve that, getting these values of 1, 0, 3, 6, we should just say do a mod. So this would technically x is going to be 0, 1, 2, 3, 4, 5, 6, 7, 8. If we do x mod 3, we're going to get 0, 1, 2, 0, 1, 2, 0, 1, 2. And then if we multiply that value by 3, we'll get 0, 3, 6, 0, 3, 6, 0, 3, 6. So that'll help us to choose our x. How do we choose our y? It only increases every 3 we go. So we gotta divide by 3 and floor it. Every 3 we go 1 down lower in the y, but we also have to multiply it by 3. So it makes it so that 0, 1, 2, 3, 4, 5, 6, 7, 8. Every time we increment x by 3, we go down 3 rows. And then we need to determine where we actually are in the table, and y helps us to do that, or at least where we are in the subtable. So this is where we are in the actual Sudoku board. So I'll have to put those in parentheses, but this is where we are in the subtable. And it's going to be very similar. The x is going, or the y is going to be modded by 3. Every time the y increases, we'll reset the x at 3. Similarly, we're going to do math.floor of y divided by 3. Only go down 1 every 3 that we go. All right. Well, when we've done all that, we can run it. We expect the true, got a false. So let's figure out which false we're going down. Add some logs for each one. Just so we can know what our potential, if it's subbox, it'll probably be a little bit easier to solve. Not easier to solve, but there's more potential for change. Make sure we're using the right variables. So we could also log row X, Y, just so we know where we're getting. Column X, Y, and then finally sub X, sub Y, X, Y. We gotta ignore periods. That seems pretty obvious. So column is not equal to dot n. And then we'll take this logic. They're all looking at the... Do we even need to do all this? Yeah, we do. So we do need that. Do this, except it'll be row. We'll do this, except it'll be sub. Well, sub box. Change all the subs to sub box. We'll do sub box X, sub box Y, sub box X, sub box Y. And we'll try running it. Update all variables, very important. Run it. Okay, so the sub box is the issue this time. I am gonna wrap this in an object so it's easier to know which variable is which. And for sanity, the sake of sanity, I'm just gonna double check, make sure we're not reusing these variables. These are consts, so the order should be pretty strict. This is sub box, scene sub box, scene sub box. Oh, there it is. As a row. We have two passing test cases. We can submit it. We'll probably get a slow timer because we console log. We do have a valid solution. So let's remove the logs in hopes that we improve performance a little bit. Nice, so we cut off about 10 milliseconds there. So just looking for opportunities to improve performance here. I'm curious about this part. Since X hardly changes, we could cache this value. Call dx. We could say const dx equals this thing, and dy, and say const dy equals this thing. That's one opportunity. So let's run it again. See how we do. So we're at 4 milliseconds. We'll submit it. See if we do. We'll probably at 10 seconds. It's usually how it goes, but not this time. Which is totally fine with me. I do wonder if just using a object here is going to be faster for us. And if we do, and then if we do something like this. And then finally, let's see. Just replacing our sets with maps, well, objects, in hopes that it makes things a little bit more performant. So we'll run it again just to make sure to get a quick run of our code. And we have an extra parentheses, so nice. Run it again. And then we'll submit it. And we're at 4 milliseconds. Hopefully we didn't increase it, and we did. Now there's a chance that we just got unlucky with that run. But I'm not really seeing any concrete way to really improve performance here. There are probably like some secret Sudoku approaches to know if it's valid or not, but I'm curious what the better solutions ended up doing. So I'm gonna move on to that. Delete this. I'll go to here. Wow. Yeah, like they're writing a file. I didn't know you could do that. Wow, so they make a set for all the different scenarios for each row column. Oh wow, okay, so they basically okay, so they go through each row and column once, and then they look at each individual. They consider each cell for all 3 scenarios, which is what we did. I think the advantage that they had is I'm not looking at the same cell actually, now that I think about it. They look at the same cell and they're like, okay, well, what is that cell in terms of row? What's that cell in terms of column? What's that cell in terms of subbox? But for our code, we were like creating this virtual index into the double array, and this virtual index was covering a different column, a different row, and a different subbox in terms of the cells. So we're actually getting 3 different values and checking all 3 different values. They were able to just look at the cell, see if it's a dot. So they were able to get away with doing this check only once. It's actually pretty smart. I do like that approach. I do think it's a smart approach. It's probably one of the scenarios where it depends on what order you did things. Maybe you would do things slightly different. But I can understand why there's this, it's probably considerably faster. But they did do the division. They didn't do any mods though. They I think that you could get away. No, you don't. It's just very simply put, you don't need a mod because you're just jumping to a different box, divide it out, multiply by 3 to jump around. Cool. Yeah, that's a pretty smart solution. So that's another medium. Let's do another one. Let's take a look at this. Divide two integers. Okay. Given two integers, dividend and divisor. Divide two integers without using multiplication, division, and mod operator. The integer division should truncate towards 0, which means losing its fractional part. For example, that 8.345 would be truncated to 8, and negative 2.7 would be truncated to 2, so negative 2. Return the quotient after dividing dividend by divisor. Note, assume you are dealing with an environment that can store integers. For this problem, if the quotient is strictly greater than return, if the quotient is strictly less than, then return this. Okay, so we're not allowed to use multiplication, we're not allowed to use division. So I'm actually curious why this would be considered medium. So the first thing that comes to mind is the naive solution. Basically, the idea of if the only thing that complicates it is signage. So I'll do math.sign of dividend equals math.sign. Let's look at the constraints. Divisor's never 0, so that's helpful. Divisor. And my naive solution is just to run a for loop and subtract until we hit the value. We're not allowed to use multiplication, division, or mod. So no mult, div, or mod. And commas. So if they have the same sign, then we could just subtract one from the other. We'll do while. We'll do const let result equals 0. We'll call it quotient. And we'll just return quotient here. While dividend is greater than divisor, dividend minus equals divisor. And then we'll have else. And we also need to say quotient plus plus. Very similar solution, except this part is a little bit harder. It probably becomes easier if they both have the same sign. So, and we just return negative quotient. So I'm gonna do dividend equals math.abs dividend, and divisor equals math dot abs divisor. Something like that. We can actually just do minus minus. That way we could just return quotient at the end. And we could just run it. We do pass. I'm curious if there's a optimization here that I'm not thinking of. Equals. Very easy edge case. Totally missed it. -1, -1. So they do have the same sign. Well, interesting. Do A, B, A, B, A, B, A, B, A, B. Sure. Run it. Submit it. Time limit exceeded. The divisor is -1. Do we add base cases? I guess we could add the base case. We'll do const is scene equals this. We never did a const here. Let here. And we never let there. I suppose we could do another chain. And we could say if divisor equal 1, if B equals 1, and we'll return is same. B equals 1. How about this? If divisor equals 1, return dividend. If divisor, no, that doesn't work either. Does it? Return negative dividend. Something like that. I'll run it. We'll submit it. Oh, then there's the range requirement. So in order to do that, we'll take these, put all this code in here. We'll put dividend, divisor, and then we'll do return math dot max math dot min, and then the biggest thing, I'll do min on the outside. So the biggest thing we want is 2 star star. Let's look at the description. 31. Why do I always do this? I want the smaller thing on the left. 2 star star 31 minus negative 2 star star 31, 2 star star 31 minus 1, and then there's fn dividend divisor. We'll run it. Doesn't like the minus sign, I think. And then this one, it probably doesn't like the minus sign as well. So we'll run it like that. We didn't put a comma. So let's run it like that. Let's take a moment, take a breath. And we'll run it. And that works, so let's submit it. Time limit exceeded. Why? Am I not passing an argument? Dividend, divisor, dividend, divisor. Divisor is -1. Divisor is -1 is negative dividend. Do a log of all the variables. Just like that, and we'll submit it. It does not log anything. How fast does it want it? Run that. How fast do you want it to run? Do I need to like cache this? Submit it. How do you make it faster? Do this. We'll do const max equals bound -1. Const min equals bound negative bound. Max, return max. If result is less than or equal to min, return min. Otherwise, return result. How fast do you want this? I am so confused. How fast could they possibly want this to be? I'm curious what's faster here. There's a doing a POW or doing star is faster. I'll just put the -1 first. Oh, this would be interesting. What if we did... and then we just did multiply by the divisor. That seems like a horrible idea, but I don't think that optimizes at all. But there's less code. What do you mean time limit exceeded? How do I run it faster? Let's undo. Okay, just put the -1 first. Wow, I have no idea how to make this faster. What if I didn't log? Is this even possible in JavaScript? What if we got rid of this and got rid of this? We're at 993. We actually got to the output. I guess what if we don't call a function then. And then we put the quotient earlier. Here we say do all this. And we'll say quotient equals dividend times divisor. And then we'll do else. And then we'll leave all this. Get rid of this. Run it. This is a let. Run it. Shouldn't be result, should be quotient. Submit it. Oh. We're hitting the time limit at an earlier case now. How is that possible? Don't need a variable for this anymore. I don't know that we ever did. What is different? This almost just feels like I picked the wrong programming language. Test 17. This was passing just fine before. These are both very similar code, but the only difference is the quotient. How the quotient changes. So I think technically we could do this. We could say quotient equals negative quotient. We can get rid of that else. We can untab this while. It's just less code. Submit it. spelling issue. Running it. Oh, we're at 509. Divisor is 3. We got -3. Oh, they gotta be not equals. And somehow we're back here. Are we just getting unlucky? Okay. I'm not sure if there's a secret here. I wonder if I should just look at the solutions, or maybe there's a hint. I don't think that that's right. I was thinking of doing that, but we can do bit manipulation. I mean, that's fine, I guess. It does it in, it would, I guess it does it considerably faster. Fine. But it doesn't do, oh yeah, it does do that one faster. Okay. So I think what we need to do is A, B, and then quotient equals wrong direction. +1. I'm not sure if that's correct. Might be off by 1 in some cases, or just completely wrong. In this case, I think we need to. It is this, and we gotta do while b. Hopefully now it's just off by 1. We are off by 1. Question is, we went 1 too many. Probably because of this +1. I think we do need to add one at some point. But every time we do this, it just assumes that the output is always odd. This is not nearly as fun of a problem. Bit manipulation is just not like really algorithmic. It's just testing your knowledge. I feel like this has to be greater than 2. Because I think in this case, 7, we would cut off the 1, which would bring it down to 6. And then we'll bring it down. Actually, it wouldn't be. What would it be? Eventually, it would just be 1. And then I think like if A and B, which in ++. I think this could be greater than or equal to 2. So what does 10 look like in binary? 8020 is 10. And then it becomes 101, then it becomes 10, then it becomes 1. So and then the 3 is also 3 is just 1 1. So this is saying only run it once. Maybe while B. Gosh. Well, it's greater than something. What if quotient started out as 1? Didn't do the +1? Oh, because that would assume that it's always even. This would become. We got to. Maybe it's. Maybe it's a is greater than or equal to divisor. What is A? A is 1 0 1 0. I feel like A would become 1 0 1, which is 5. Oh, well, we fixed one, but broke another. Output is -4, 1 and -2. Oof, okay. So this is 7 is 1 1 0. -3 is complicated. But we do simplify it by absolute valuing. So it just becomes 3, which is just 1 1. So it should close it open twice, which squares it. It should be 2. Now 3 I can understand, but 2... If I got 3, I would understand that, but why do I get 4? A is greater than divisor. What is A? What is divisor? We know what divisor is. It's already there. We'll run it. A is 1. It's fair. Oh my gosh. It's negative. Well, that'll get us to -3 at least. Then the question is, how do we get to -2? I don't know, something about this being greater than 1 seems important. This is gonna break the 10 though. Let's fix this. Zero, 1, 0. 0, 0, 1, 1, 0. This should be 1, 3. Why aren't we getting at least 3 for the quotient? I expect for the first one we add 1. Then the second one we would move it over, which would make it 2, add 1, which would make it 3. And this would be 2 as a remainder. Is 2 greater than 3? No, so we shouldn't do this. So I'm not sure why we're not getting 3. seems like a logical point in that direction. Hey, advisor. A is 5. That's because we're opting out early. Oh. These are both odd, right? They both are odd. Alright. I think I'm gonna just look at the answer. I think I've by 2 integers. Need to subscribe. So they do care about this idea of being positive. That's a cool idea. They do take the absolute values, which I did. They do +1 and binary shift. B. Oh wow, interesting. Oh, that's really smart actually. They just keep summing it until, oh my gosh, of course. Just increase the quotient. But this is still linear. Are there any other operations that happen on Q other than this plus plus? Oh, but we reset Q here. So there's this, oh, there's this answer. Oh my gosh. It's just like figuring out bit by bit. That's crazy. Okay, I got it. Figure it out bit by bit, of course. It's a cool idea. Not a fan of that problem. What's count and say? The count and say sequence is a sequence of digit strings defined by the recursive formula count and say 1, count and say n. It is run length encoding count and say -1. Fine. So I'm just gonna write the definition. N equals 1, return 1, return count and say n -1. That's just what these are saying right here. This is a base case. This is the definition of what n is. Okay. So run length encoding is a string compression method that works by replacing consecutive identical numbers repeated 2 more times with the concatenation of the character and the number marking the count of the character length of the run. For example, to compress the string 3, 3, 3, 2, 2, 2, 1, 5, 1, you replace 3 with 2, 3, replace the 2 3s with 2, replace 5 with 1, 5, and replace 1 with 1, 1, thus compressed. I can hardly call that compression. Given a positive integer n, return the nth element of the count and say sequence. I'm not really 100% sure if this makes sense. It's a string compression method. Works by replacing consecutive identical numbers. Given a positive integer n, return the nth element. Input n equals 1, output 1. One, two, one, one. It's the run length encoding. Count and say n is the run length encoding of this. Then that's the run length encoding of that, and that's the run length encoding. Run length encoding. This is kind of wild in my opinion. Okay, so we need like another function. And then what do you want? Return the nth element of the count and say sequence. But n also tells you how deep to go. Okay, so we need two functions here. We are gonna need something like that. We'll do like const fn equals. This takes an argument of n. And then we need another function which takes a input and then does something. And then this returns const result equals fn sub n. And then we return result sub n. Minus 1, apparently. We can inline it. So the idea here is this one we just return a string one, then we'll do RLE on that, which would we'll have like a const result equals empty array. We'll do return result dot join of empty string, and then we'll do for let I equals 0, I is less than result input dot length I plus plus. And then with let count equals 0 and start equals input sub I file input sub I equals, we'll do count 1, we'll do I plus plus, that's fine, plus code, count plus plus, Yeah, we need both. I guess we could do this, and then we could do, which allows us to get rid of count. And then we can do result.push input sub start. And what is it? The number is first? The number is first. Something like this? Input is undefined. I guess we'll do a console log, RLE, input, run it. RLE1, RLE1. Oh, this should be, I don't think we need to do y plus plus here. That happens in that while loop. And we do I minus start. So we're trying to figure out why we're getting a null pointer exception, or this undefined exception. RLE is taking count and say and -1. Eventually we hit this, which we'll put in string here. Pass in the string, that's why this is 1. And then we'll return that to the parent. Let's console log the result as well. One is nice, but then why do we get RLE 1? We should get 1, which then would become 2, 1. So I'm not very certain why. Just for the sake of sanity, we're going to also log that. Is 1, 1. Oh my goodness. It's FN. We had to call this, not this. Oh. It's funny. So one thing to consider doing here is just log the result. We get 2 on, and then we get 1, 2, 1, 1. The output is 1. What? Wait, what? I thought... Oh my gosh, I didn't even understand the problem. thought you wanted the ith element. I think we can get rid of this. We could run it. We could submit it. Oh, we did horribly. How do you do better? Let's find out. You could do it without recursion? What? Oh, of course you could do it without recursion. Because you need the base case. Okay. Yep. Sol equals current. Current is empty string. Count current sub interest. So I just did the same thing without recursion. I mean, it's fine. That seems to be the best way. Don't use recursion. Back to my code where we did use recursion. I would probably have considered not using recursion if they didn't define it using recursive statements. So they actually kind of tricked me, which is kind of dirty. Can you solve it iteratively? Of course. Well, now we can. Okay, back to the problem list. I want to do one hard. I think it'd be good. Oh, that sounds brutal. Do I dare? Write a program to solve Sudoku puzzle by filling the empty cells. The Sudoku solution must satisfy all the following rules. The dot character indicates empty cells. It's guaranteed that the input has only one solution. Oh. Wow. I do think this is an interesting problem to solve, though. The only question is, how do you actually solve it? Like, the only thing that really comes to mind is just like doing the obvious stuff. But beyond that, I can't, like, if there's a column or a row where only a certain number will go, that's the only thing I can think of. But if the Sudoku board is not filled in enough, I do need a hint, I think, immediately. Oh my gosh. It's just like brute force? That's crazy. There's no way. That's crazy. I don't want to write a brute force algorithm. That's crazy. Let's find another problem. What's n queens? The n queens puzzle is a problem placing n queens on an n by n chessboard such that no two queens attack each other. Give an integer n, return all distinct solutions. To the n queens puzzle, you may return the answer in any order. Oh my gosh. Q and dot. Oh my goodness. That doesn't seem interesting either. What's trapping rainwater? We have an n non-negative integers representing the elevation map. The width of each bar is 1. Compute how much water can trap after raining. The above elevation map is represented by an array trapped. 2, 3, 4, 5, 6. Solved a similar problem to this. I think in the medium category, where it's just you just have to care about the two highest things, but now the things that are lower actually affect the algorithm. For each one, how do you not duplicate? How do you not duplicate? Because like for this one, I would probably be like, okay, I'm here. I need to go over 1, 2, 3. Oh, I hit a wall. The sum of all these would be water. But how do you not go here? I guess you only count these. And so for this one, you only count this. For this one, you only count these 3. For this one, you only count this one. For this one, you immediately hit a wall, which means you get 0. This one, you never hit a wall. This one, you hit a wall, which gives you 1. I have an algorithm, but is it efficient? I don't think so. But it's something like for I equals 0, I is less than height dot length, I plus plus, let total equals 0, return total. I think ultimately the question is going to be, how do you make it not n squared? Because the default algorithm I have that comes to mind is n squared. But basically, we want to do for let j equals 0, j is less than height dot length, j plus plus. If j height sub j is greater than or equal to height sub I, then we found the wall. And then the total will be plus equals j minus I. Minus 1? Because in this case it would be, let's just say 0. 1, 2, 3, 4. 4 minus 0 is 4. Minus 1 is 3. That checks out. and then we break. And then if we don't hit a wall, like at the end, then yeah, we don't count it. I think this algorithm works as it is. What? Negative 57. What? I is smaller than J. Oh my gosh. I plus 1. Okay, at least we have a positive value now. So I don't have enough, I'm not getting enough water, which says that there's like a potentially further wall that I'm not considering for one of these. 2 can go to 3, 3 can go to 5. I'm wondering how much it helps to draw this. So 5 is the highest, so we'll do dot 3, 4, 1, 2, 0, 1, 2, 3, 1, 2, 1, 2, 3, 4, 5. Okay, so I can see 1, 2, 3, 4, 5, 6, 7, 8, 9. I guess there's this aspect of the amount of water that would be above. So if this was actually higher, then it would be 2 times the, I don't know, the height difference. I would almost have to look at the height of the next thing compared to this. Because basically this is the only opportunity I'm giving it to count these 3. And if this was higher, then it would be these 3 as well. It's not simply the difference. My current algorithm, I would count these 5. I feel like I should count this 1. I would count this 1, but I would only count one of these, not both of these. But we are missing 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. So which of these 3 am I not counting is the question. Actually, I'm probably not counting these 2. And I'm probably not counting this 1. So I think we need to say like const next equals height sub I plus 1 or 0. And we do need to care about the next one's height. And we need to care about how high this one goes. It can't be just, because if this is really high and this is high enough, it doesn't have to be greater than or equal to, it just needs to be amongst the highest. But then if there's just like a jagged one here, that makes it harder. Okay, this is what makes it hard. Maybe it does need to be n squared. You just have to go until you hit a wall. But you have to keep track of the highest thing you've seen. You have to do like const max equals 0. And then like max equals math.max of max or height sub j. I think we have to break here. And I think we have to store j. And I think we have to store I. J. I. Yeah. So we would have the highest thing that we're competing against. The only question is, if something was popping out of the water. Something was popping out of the water. This was higher. How do I... take a look here. Always harder than you think. I feel like we gotta get like also the smallest thing. No, not the smallest, like the second biggest thing. Like something that has the potential to interrupt us. For now, I'm gonna do total plus equals. We're gonna see if max is greater than or equal to I. Then we'll do total plus equals max minus I minus 1. We should still get 6. Assignment to a constant variable. Right. Okay. Okay, I'm fine with that. This isn't correct. It should be height of max greater than height by no, because then that'll just be minus 1 if max is greater than I n. I guess that's fine. No, we need both. Okay, cool. We're back to the failing test case we had before. So yeah, we're back to the question of how do we detect these two? And how do we detect this one? I do think that there's some potential to care about getting these two. I don't know. I could just like go through it again with one less height. And then this seems horrible. Okay, what if I'm thinking about this kind of wrong? What if there's a smarter way to do it? Almost like simulate rain. Seems like a horrible idea, though. I'm very curious what the heights can be. Very large. The heights can be very large. So it's not a matter of just like filling up water, unfortunately. Because my idea was to kind of just like find the gaps and start filling them with water slowly. Let's see if we can get a hint. Let's see if we can look at the topic. Okay, so dynamic programming is part of it. 2 pointers is another part of it. Yeah, this one's a tough one. Very curious about it. I do think I'm gonna have to look at a solution because it seems like it's slightly out of my depth. I did do this one. This is the one that is, I would say, is very similar. One idea I have is like to actually simulate rain falling. In each bucket and see if the water collects. Let's just see the solution. Alright, two-pointer approach. Water in any position depends on the maximum bar to left and right. I agree. Instead of pre-computing with extra arrays, we can use 2 pointers with running max values. Okay. Maintaining 2 pointers left and right. Okay. Track left max, right max. Sure. If the height of left is less than the height of right, then the water trapped on the left depends only on left max. And then if height of left is greater than left max, update left max, else left max minus height. Move left, else do the same for the right using right max. So if I were to translate this into just plain old English, the height of the thing on the left is less than the height of the thing on the right, and the water trapped in the left depends on left max, which is the highest. Yes, because this is lower than the height on the right, then depends on this. If height left is less than left max, then update left max. Oh, sorry, if it's greater than. Okay, so yeah, if it's greater than, then that's the new max. Else, add left max minus height of left. Oh. Add it to what? Ooh, interesting. Wow, look at that. It doesn't look terrible, I guess. It's not cursive, is it? No. Please upvote, please. I didn't even know upvoting was a thing. If your solution is clear, I'll upvote it, sure. N equals height.length. I'm curious about that. I'm not sure if it's necessary. Thanks, Yash. Thanks for the confidence. There's the left, there's the right, which is the end of the array. There's your max on the left and the right. There's the result, which is 0. So where are we starting? We're starting from the edges, and then we're kind of working our way into the middle. So the height of the left, if the thing on the left is currently lower than the thing on the right, then we'll do this. Otherwise, we'll do that. The thing on the left is greater than the maximum thing we saw, and the max on the left becomes that thing. Otherwise, we accumulate water. And then we do left plus plus. Okay. Okay. That seems pretty clear. So basically we keep track of the walls and then we accumulate water as we work from that wall to the inner walls. Okay, I think that's pretty clear. I'll upvote it. Yep, that was a good, it was very, yeah, clean explanation. How do I upvote it? Oh, right here. Nice. Suboptimal. Our only constraint is left max. Is that how the algorithm works? No, there's left max under straight max. Yep. Okay. I do think that I need to stop here though. I unfortunately couldn't really figure out the hard problems, but I'm going to see if I can remember this tomorrow, and I'll attempt to solve it tomorrow without looking at the answer again. But yep, that's it for me. Thanks for joining in, everyone. Thanks for the support. Thanks for the kind messages. I'll be on again tomorrow about the same time, so I'll see you then. Bye for now.